Alright guys, so in our second lesson on parabolas, today we're going to be looking at how do we take an equation and put it into this form so that we can graph it. Okay, so in our first lesson we looked at just how you would graph these, right, and all about the graphs of parabolas, but today we're going to look at what if the equation that we're given is not written in this form, how can we make it into this form? Okay, and so if you go down kind of to the bottom of page 1, where you see this, it says how to complete the square. So here's kind of the issue on this, and I'm going to give you just sort of a made-up example here because I want you to see something first, is what does it even mean to have a perfect square when we're doing stuff like this. So consider this trinomial for a minute. If I said x squared plus 6x plus 9. So if I asked you to factor this, we would look at this and we would say, okay, well then what are numbers that multiply to be 9 and that would add to be 6? So I'm trying to think of two numbers that multiply to be 9, and if I were to add them together, they add to be 6. Right? That's how we factor a trinomial like this. And so if my numbers are positive 3 and positive 3, we would write that as x plus 3, x plus 3. And you could always check your answer if you really wanted to. If I were to multiply those together, it does give me back what I started with, so I know that I did that right. Well, because they are the same factor, instead of writing them as two different factors, I could simply say that that is x plus 3 squared. Right? And that's what we're looking for when I have a quadratic like this, is I need this information, because if you go back to vertex form of a parabola, if you see this guy right here, right, this is the look that I need in order to know what my h value is and what my k value is. So we are trying to create this scenario that I see right here. That's the goal. So I need it to look like this. So right now in this problem, they're not giving it to me in that format. The format that you're seeing right here has this look to it. It's something x squared plus something x plus a constant. Right? This is the general form that I'm seeing for this. Right? This is more of what we might call standard form of a quadratic. Right? We want vertex form. So our goal is to be able to take it out of this form and get it looking more like it did in lesson 1 so that I could be able to graph it. So let's look at this process for a minute. If I were to factor this, which this one's not even factorable, but I can't even come up with numbers that would multiply to be -4 that would add to be 8. Right? Those numbers don't even exist. So this is definitely not a perfect square the way it's written right now. So how do we know if it is a perfect square? And if it's not, how do we make it one? So you look at the c value, that's this guy. So what do we need our c value to look like? In order for this to be a perfect square, our c value needs to fit this description. If I look at my b value, I should be able to take my b value, divide it by 2, and square it. Whatever this answer is what this number needs to be. And if it's not that already, then I need to create the scenario that makes it a perfect square. So if you look at this one, and I'm actually going to take this equation, so x squared plus 8x minus 4. So I'm going to take that expression, I should say, and I'm actually going to make it an equation because I want you to see something on this. This is what most of our problems are going to look like today. It's just going to equal 0. But as I look at this, I can tell that that is not the number that fits this description. Right? If I took 8, my b value is 8. If I said, well, what's 8 divided by 2? That's 4. And 4 squared is 16, which means I need this number to be 16, not -4. So what I'm actually going to do is I'm going to take that -4 and just move it over to the other side to get it out of my way. So I'm going to say x squared plus 8x, and I'm going to add 4 to both sides so that I can move him over to this side and get it out of the way. So now let's complete the square. That's why we call this completing the squares. We're going to now create a perfect square by putting the c value here that actually needs to be there. So again, you're taking your b value, which is 8, divide it by 2, which would be 4, and then square that number and now I get 16. So for this problem, my C value needs to be 16. So I'm going to put a positive 16 right there. Well, you guys have heard the rule a long, long time ago in all throughout algebra, right? And even pre-algebra, that they would say whatever you do to the left side of the equation, you got to do to the right side of the equation. So I'm going to actually put a plus 16 on this side as well. Right? I can't just throw in 16 out of nowhere. It would make my equation no longer balanced. Okay, and so if I'm going to do something to the left side, I also have to do the same thing to the right side. Well, the right side is simply, if I combine those, would simply be 20. What about the left side though? If I were to factor this, well, what are two numbers that would multiply to be 16? That would add to be 8. So if we look at that, we should be able to recognize that 4 times 4 is 16, and if I add them together, I get 8, which means my factors are x plus 4 and x plus 4. And what you guys saw over here is when my factors are the same, I can write it this way. So if my factors are x plus 4 and x plus 4, I could actually write that as x plus 4 squared. It's going to bring down my 20. So as I now look at this, this is now a little closer to the vertex form that we were looking at in our first lesson. The one extra thing I'm going to do on this is, before I can determine all the pieces, I really need all my information on one side of the equation, because as I look at this, right, where this said y equals, and that all of my information was on one side of the equation. So to finish this off, I'm actually going to take that 20 and bring it back over. So I'm going to subtract 20 from both sides. So it looks like this. And now that I have all my information on one side, now I can identify all the important characteristics that we talked about in our first lesson. Right? I can now look at this and I can say, well, here's my h, here's my k. So if I wanted to identify a vertex of this, I can see that my vertex would be -4, -20. I could see that my axis of symmetry runs through x equaling -4. Right? And so now I can get all this important information, and I could actually put this into a graph, just like we did in our first lesson. Okay, and so that's the main focus for today is going to be getting equations that are in standard form and converting them to vertex form so that we can pick out the vertex and graph the problem. Okay, so I'm going to actually turn to page 4, which looks like this. And we're going to do the 4 problems on this page together as our lesson, and then if you turn the page, the next page, which is page 5, looks like this, has 6 problems on it. You guys are going to do these 6 for your assignment. Okay, and so let's go back to this one, and I want to go through this process with you on all 4 of these, so we get plenty of practice today. All right, here we go. So guys, one of the first things we talked about is, in order for me to put this into vertex form, I need this to be a perfect square. And the way that I see it right now is, if I were to say, well, what are your factors of -12 that would add to be -4? It definitely is not going to be a perfect square, right? You know, the only way that that could be a perfect square is if my factors of this are equal. And when I add them together, I get this. Right? Just like we saw in the previous problem. So that means I need to get 12 out of the way. So I'm going to add 12 to both sides. I always leave myself a little space right there because we're going to now put a number in there for our C value in order to complete the square. So remember, how do we figure out what our C value should be? So we saw this little formula on the previous page. It looks like this. So let's take our B value, which is -4. We're going to divide it by 2, which would become -2. But -2 squared would be +4, which means I need to add 4 right here. Now I have a perfect square. But one thing you can't forget to do is whatever you did to the left side, you got to do to the right side. So I'm adding 4 to both sides of the equation. So there's a super important step. So now let's simplify each side. Let me just start with the left side. So if I told you to factor this, I would say, what are the two numbers that multiply to be 4, that add to be -4? Well, those numbers would be -2 and -2. And notice they're identical, which is what we're shooting for. That's how we know this is a perfect square. So, and that's always going to be the case as we go through this process. That's how we know it's working. So that means my factors are x minus 2 and x minus 2, which means I can now write that as x minus 2 squared. So that's the left side of the equation. On the right side, if I add those together, I get 16. But remember, in order to be in vertex form, I really need all this information on one side of the equation. So I'm going to subtract 16 back over to this side of the equation. There we go. So now it's in vertex form. Now I can graph it. So we are going to graph these today. So this kind of is same thing you did in lesson 1, but with the extra process of getting it into the correct form. But now I should be able to look at this and identify my vertex, which I can see is +2, -16. I can see that my axis of symmetry is x equals 2. So let's start graphing this. Now, some of these numbers were not very friendly for these graphs. Like 16 is a pretty big number. One thing you can do is make it so that these numbers fit on the graph by counting by, you could count by 2s, you could count by 4s, whatever allows you to get this to fit on the graph here. So let's see, that's going to be pretty low. So I'm going to draw my x-axis like way up here. So this is my x-axis, and I'll put my y-axis right here. All right, so I'm actually going to count by 2s just to make this fit on the graph. So I'm going to go right 2 and down 16 to get my vertex. So I'm going to go right 2 and then down 16. 1, 2, 3, 4, 5, 6, 7, 8. Because remember, I'm counting by 2s on this. So that's actually at -16. And even though I went 1 unit to the right, since I'm counting by 2s, that was actually right 2 and then down 16. So I'm counting by 2s on this one. Okay, so we learned last time that I have the axis of symmetry running right down the middle of this. So here is, I'm going to change the colors here so that I don't get confused on what's what. So here's our axis of symmetry running right there. So we're going to do one little extra element today to get more accurate graphs. Okay, we're going to make these more accurate today. So if I see that my graph is going to open upward because my a value is positive, instead of just sketching the curve, right, which really isn't very accurate. I mean, it's going to go the right direction, but we really don't know how wide or how narrow this curve should go. So what we're going to do is I'm actually going to pick a couple other points to plug in for x in order to determine what the y coordinates are. So as I see it right now, I can see that +2 is the middle of my graph. So what I'm going to do is I'm going to pick 2 other numbers next to this that I can plug in. So if this is +2 is the middle, then I might use numbers like +1 and 0 as my other x's. So we're going to plug those in for x in order to get y coordinates. So as I look at these guys, so I'm going to plug a 1 in for x, and I'm just going right here to my finished equation. You could do it on this one too, it really doesn't matter. But we're going to be working with these guys today. So if I put a 1 right there, well, let's simplify that. 1 minus 2 is -1. -1 squared is +1. Minus 16 would give me -15. So there's one of the points on my graph. Now let's do this one. So if I put a 0 in there, so 0 minus 2 is negative 2. Negative 2 squared is 4. And 4 minus 16 is negative 12. So if we plot those points, so let's see, 0, negative 12, 1, 2, 3, 4, 5, 6. And 1, negative 15 would go right there. So what we're basically seeing on this is I am now seeing the left half of my curve, right? And now it's a much more accurate curve because I'm actually going through some real points on the graph. Well, what about the right side? Well, remember, there's a reason we call this the axis of symmetry, right? Symmetry means the left side is exactly like the right side. So this little point that I have right there, all I'm going to do is mirror that over to the other side. And I'm going to take this point and mirror that over to the other side, right? So that my left half looks exactly like the right half. Now I can draw my curve. And now I have a more accurate curve than what we were doing in our first lesson, because we're actually going through some real points on the graph. All right, let's go over to this one. So in order to complete the square, again, we need to recognize what this needs to be in order to be a perfect square. Well, on this one, you might notice this one is already a perfect square with the way that it's written right now. All right, because remember, if I look at this formula right here, what does my C value need to be? Well, if you took this B value of negative 8 and put it right there, negative 8 divided by 2 is negative 4, and negative 4 squared is 16. Well, this one already has 16, so we already have a perfect square, so I don't even have to go through the extra steps that I did right there. It's already a perfect square. So let's just factor it. What are two numbers that multiply to be 16 that add to be negative 8? Hopefully we're seeing that as negative 4 and negative 4. All right, those are two numbers that multiply to be 16, and if I add them together, I get negative 8, which means my factors are x minus 4, which we can write as x minus 4 squared. I'm going to bring down the right side. And then the one last thing is, remember, we like to have everything equal 0, so I need to subtract 5 over to this side. And now that I have everything on one side of the equation, I can graph it. Right? So like on this one, again, I'm going to look at this, and this just goes right back to our previous lesson, but we can see that our vertex would be at positive 4, negative 5. I can see my axis of symmetry is x equals 4. So these aren't too bad of numbers. That one should fit on here okay. Let's see, 4, negative 5. So I'm going to kind of move my y-axis to right here. And I'll put my x-axis, maybe about here. All right, so now when I plot my vertex, 4, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. It's going to go right there, nice and pretty darn central within the graph. Here's my axis of symmetry is at 4. Right there. So again, I already know that this is a graph that will open upward because this is positive, right? So if it's going to open upward, then I don't just want to draw the random curve. I'd really like some real points. So here we are, we're centered at 4. I need two numbers to one side, either left or right. So if I'm centered at 4, I'm going to use numbers like 3 and 2 as my x's to get a couple more points on this graph. So if I plug my 3 back into this equation, I know 3 minus 4 is negative 1. Negative 1 squared is positive 1. Positive 1 minus 5 is negative 4. Let's put a 2 in there. 2 minus 4 is negative 2. Negative 2 squared is 4. Minus 5 is negative 1. So if I plot those points, 1, 2, 3, here's 3, negative 4. Here's 2, negative 1. So remember, I'm now looking at the left half of my graph. In order to get the right half, all I have to do is mirror those points onto the other side. So that guy is going to get mirrored over to right there. And that one is going to mirror across to right there. And now we have a much more accurate graph, which will look like this. All right, let me take you down to these guys. This will be the same process, but I'm going to show you these are just kind of start out with slightly different scenarios here. As I look at this one of the things I'm seeing on this is that negative right there. I really don't like my leading term to be negative if I can help it. One of the things that we can do today is, because this is something that equals 0, is I can manipulate these a little bit, because this is just an equation, right? So one of the things I could do is I could actually take all this information and move it to this side of the equation. So if I take this and I add x squared over to here, well, now he would become positive. So here's what this is going to look like. So I'm essentially taking all three of those and I'm moving them to this side of the equation. So I'm going to add x squared over to here so that it becomes positive. He was already positive, so I'm going to have to subtract 8x over to this side. And he was already positive, so I'm going to subtract 84 over to this side. But at least by doing that, my leading term is now positive. And so now it's going to be a little easier to work with. We'll get to the negative stuff within our next lessons. Today's you can make them all positive. So as I look at this, let's go through our process. Again, this is not a perfect square the way it's written right now. So I need to start by getting him out of the way. So I'm actually going to add this 84 back over to here. So I guess we could have left it there. I just wanted to show you how we can move all this to one side. I'm going to add 84 back to this side. So we're back to looking at that formula to say, okay, what number needs to go here in order to create a perfect square? So remember, you take your b value, you cut it in half, so it becomes negative 4, and then you square it, and we get positive 16. But whatever I do to the right side, I also need to do to the left side. So I'm going to add 16 to this side also to keep my equation balanced. Well, the left side, pretty simple. That's just going to be 100 when I add those together. What about the right side? Two numbers that multiply to be 16 that add to be negative 8. We've already seen this one. They're going to be identical. That's because it's a perfect square. So if my factors are x minus 4, I know I can simply write that as x minus 4 squared. That side we already identified was 100. But to really have it in vertex form, I need everything on one side. So I'm going to subtract my 100 over to here. Now it's in vertex form. Now I could go through the graphing process like I did on the last couple. These numbers are really ugly, so you definitely would have to count by something unique to get it to fit on this graph. I'm not even going to try to graph this one because the numbers are so ugly, but I'm going to go through the process real quick. Right? I can tell by the numbers that my vertex is 4 and negative 100. That's where the vertex would go, which means my axis of symmetry runs through x equals 4. So again, keep in mind, if 4 is the middle of my graph, then I want to pick a numbers on one side of that, numbers like 3 and 2, that I would be plugging in for x to get some more points for the graph. And then you just mirror those to the other side to complete the graph. But we've seen that a couple times. I think you guys hopefully will be good from there. If not, tell me and I'll go through it with you. So let's look at this one. So what if, we got a lot going on with this one. So here's what I want you to notice about this. And this is something you would have seen in algebra, but it's good review. Remember, you can do anything you want to an equation as long as you do it to both sides of the equation, like we did right there. That includes division. So one thing I could do is, if I look at these numbers, I can see that all four of those are divisible by 5. So one thing I could do to make life a little easier on myself for this problem is I could divide the left side and the right side by 5. So I'm going to divide the left side by 5, and I'm going to divide the right side by 5. So as I kind of go through the numbers over here, it's just going to become x squared plus 4x plus 2 equals negative 1. And this is just a much simpler equation to work with than this one, right? So it's going to be a whole lot easier from here. Again, we got to go through our process of completing the square. Let's get him out of the way, because it's not a perfect square the way it's written now. So I'm going to subtract 2 over to here. So it looks like this. Now we can use our formula to determine what the c value should be. Remember, we're always using this little formula right here. To determine what the c value should be. So we're going to take our b value, put it right there. 4 divided by 2 is 2, and 2 squared gives us positive 4. And if I add 4 to the left side, I got to add 4 to the right side to keep that equation balanced. Let's put this in factored form. So what are the two numbers that multiply to be 4 and add to be 4? Well, positive 2 and positive 2 would do that. So my factors are x plus 2, which we can write as x plus 2 squared. On the left side, I had negative 3 plus 4, which is 1. And again, I always want everything on one side before I finish here. So let's subtract the 1 over to this side. And now I have everything on one side, which means it's in vertex form. Let's go through that graphing process one last time. We can see the vertex on this is negative 2, negative 1. That means our axis of symmetry is x equals negative 2. And those are pretty friendly numbers here, so I'm actually just going to draw my y-axis right down the middle and my x-axis right down the middle. So our vertex would be at negative 2, negative 1. Axis of symmetry runs right through that point. Which looks like this. So again, here's kind of the key extra step in graphing today is you need to identify some real points on this graph, okay, not just a random curve. So I want to pick 2 points on one side of that red line. So I'm going to pick these guys because these are pretty easy to work with. So I'm going to use negative 1 and 0 as my 2 points. So I'm going to plug those back into my equation that we finished with. So if I put a negative 1 right there, negative 1 plus 2 is 1. 1 squared is 1. Minus 1 would be 0. Put a 0 in there. 0 plus 2 is 2. Squared would be, 0 plus 2 is 2. Squared would be 4. Minus 1. So I have negative 1, 0. I have 0, 3. And so now I'm looking at the right side of my curve. All I have to do is mirror those to the other side. Right there and right there. And now we have our perfect parabola. All right, so that's our graphing process, guys, for the ones that you're going to be doing for your assignment today. And you can check the calendar to see exactly which problems you're going to be doing for the assignment. But this is really all the work that we need to see. So we need to see the process for getting it into vertex form, as well as this complete graphing process, right? You need to state your vertex and your axis of symmetry, and you do need to find two other points on the graph so that we can graph a little more accurately in this one today.